I mean, there's a long list of technologies that initially seemed science fiction that now are a common day, including, like, for example, the global positioning system, the GPS. We have this 3D printing method that is designed to work specifically outside in open space. So that means it works great in microgravity, so it's not affected by the fact that everything floats in space, and it's not affected by the vacuum. So there's no atmosphere in space. It's all absolute vacuum, which has a few implications for the hardware.
The 3D printing in space is a way to become a space construction company. So basically, what we want to do is to be is to build large things directly in space. And we're starting from building very compact, very small 3D printers to prove the basic principles, and then on the way to the to this big goal, we'll be advancing with building more advanced hardware. We're cooperating with space agencies, with the largest space corporations.
There's always technologies that seemed ridiculous beforehand that got discovered because of the uh, space industry, including the internet could be arguably one of the results of it. So it's a long stream of technologies, but I think GPS is the best example of that.
Hi, everybody, and welcome to another Startup Row interview. This time is in English because I have the pleasure of having here with me the founders of space tech startup Orbital Matter, Jacob and Robert. Orbital Matter is a Polish-born startup focused on enabling the creation of large-scale structures directly in orbit, and they just received €1 million investment from the Romanian VC fund Early Game Ventures. And it's the double pleasure because I'm happy and proud that Robert is also Romanian. Gentlemen, thank you very much for talking to us today, and a big congrats for what you've done so far.
Thank you very much. It's a pleasure to be here.
You guys are building a 3D printer for space. I think it's pretty cool, right? But please tell us more about what you guys are really doing at Orbital Matter, and don't be shy and feel free to explain to us. Like, I don't know, like you talk to your grandmothers, or like we're five. We want to understand as best as we can what you guys are doing.
So maybe starting from the general vision. Yes, the 3D printing in space is a way to become a space construction company. So basically, what we want to do is to be is to build large things directly in space. So currently, the limitation, regardless of the size of the rocket, is that regardless the size of the rocket, you will always have the problem of lifting very large structures to space. So in order to build, for example, infrastructure on the moon or large space stations of the size that we know from in movies like Interstellar or other science fiction, um, we need to think about a way to build stuff directly in space. It's impossible to launch them from Earth in a single piece or even in multiple pieces and assemble them together when it comes to very ambitious and large projects. So that's where we see our place to enable the scalability of the structures in space in order to unlock the opportunities for space industry, for commercial purposes, but also for scientific goals, for scientific missions, for deep space exploration, and so on. So that's our grand vision to enable such great things to happen thanks to our technology. But obviously, this is quite long term. I would say all projects in space and especially in hardware are long term. And in our case, it takes multiple steps to reach this final vision. And we're starting from building very compact, very small 3D printers to prove the basic principles. And then on the way to the to this big goal will be advancing with building more advanced hardware. We're cooperating with space agencies, with the largest space corporations. So doing all we can, all the best in order to prove we can deliver and developing further our technology. And Robert obviously is the mastermind behind this innovation, the main innovator. So I believe I can leave the floor to him so he can explain how the technology works and why it's the best way to meet our goals.
Thank you very much, Robert. Please share with us.
Yeah, it's my pleasure. So we have this 3D printing method that is designed to work specifically outside in open space. So that means it works great in microgravity. So it's not affected by the fact that everything floats in space, and it's not affected by the vacuum. So there's no atmosphere in space. It's all absolute vacuum, which has a few implications for the hardware. So, excuse me. Anything you build has to survive those two uh, environmental factors, so to say. And our 3D printing technology is designed specifically with that in mind. So it's not just a copy of an existing technology that's just moved to space. We came up with it from the ground up, so it's best suited for that space environment. And our first application and our first thing we're going to 3D print is just a simple beam. So that's one of the simplest things you can print, 3D print. And the reason we do that is because, first of all, nobody else has done it before. Nobody else has shown that you can 3D print outside in space. And you got to start with a very simple, very uh, basic shape to just show that you can do it. But we also found a way to use this basic shape for something useful. So if you think in space, everything has to be packed down and to fit inside the rocket. So if you have very large solar panels, for example, they usually have to be broken up into smaller ones and then folded to fit inside the rocket. And then once you're in space, outside the rocket, you unfold them using various mechanisms and various methods. But all of those methods are very heavy and very large. And we realized that our printers can be quite small and still produce a very long beam. So I have here a model. This is basically what will fly to space in our next mission. And it's a 3D printer. So we have here the end where the beam comes out. So if you can imagine, the beam will come out on this way. And if you attach the solar panels at the end of it, as you 3D print things, you pull the solar panels with you upwards. So we managed to find a way to use this as a deployment method. And it's very small. So it's a one standard unit, which is a unit of measurement used in CubeSats, where it's a 10 centimeter cube and weighs about 2 kilograms. And from this, we can print a beam that's 2 meter long. And this ratio between this stowed or undeployed and versus the deployed version is very good, and makes us quite competitive in this deployment field. So yeah, that's the basics of it. And let me know if you have any other questions.
Thank you very much, Robert. I have so many questions after what you've told us, but also some curiosity. So how does this 3D printing work in a vacuum? And also, what kind of materials do you need to 3D print in space? I don't know, can you use just regular material like in 3D printing here to do whatever, I don't know, a cup or something like that?
Yeah, so we use a special material. It's actually a liquid, and there's multiple types of 3D printing. Just a quick crash course into it. You have the simplest one, which uses like melted plastic, and the plastic comes in like a spool. It's just a bunch of plastic wire that you melt in the shape you want. Then you have 3D printing that uses powder. It can be metal powder or plastic powder that you basically melt, for example, with a laser in the shape you want. And then the third one that's also popular is one that uses a liquid photopolymer. So that's a resin, kind of if you've ever had a dental filling and they put this plastic in your tooth and then use a UV light to cure it. It's the same kind of principle. It's a liquid under normal circumstances, but then if you shine an ultraviolet light, like a laser or a LED on it, it hardens up in very fast, in a matter of seconds. So this is the technology that we use, this photopolymer resin, because it does not need to be melted. Going back to the challenges of space, melting anything in a vacuum means that it's very difficult to cool them because you don't have air to blow cool air on it to make it cool down and solidify like with plastic. And that means it takes very, very long for the plastic to cool down in a vacuum. So we skip this issue by using this photopolymer resin that we cure with ultraviolet light very fast, a matter of milliseconds to harden up the plastic. So compared to other technologies, instead of taking 30 days to 3D print a 2-meter beam, for us it's a matter of hours, and that's very important in space because it takes a lot of power usually to print. We're also very low power because we don't need to heat anything up. So it has a lot of advantages, which is why we're using it.
Where do you get the materials needed for the actual printing process? And can you do the printer at a larger size? I mean, for when you need to print something larger, or I don't know.
Yes,
This is just a prototype to see that it works, right?
Yes, yes and no. So to answer your first question about the material, we use a material that we make ourselves using commercially available products. We modify it to suit our needs, and we tested it, and it's suitable for using in space. It has the right properties and so on. And when it comes to our prototype, so this prototype that I showed you is actually going to be a product that we'll sell as a first product, because it allows us to do something useful with the 3D printing while also showing that it works. So it will have a double role. It will be a product and also in-orbit demonstration of the basic technology, which is part of our bigger business strategy. One of the challenges with space and introducing new technologies is that the industry takes a long time to adopt anything new. So that's why you always have to do an in-orbit demonstration of your technology before you can sell it in any meaningful way. So that's the usual strategy for space companies, is they spend a lot of time and money to do an in-orbit demonstration of a basic technology and then try to sell it or try to scale it up. For us, we managed to find a way to do both with this product. So it will serve both as the demonstration and a product demonstration, not only for the technology, but also for the product, and allows us to build this space experience, space heritage for the technology by selling these small printers before we move on to larger scale printers. The advantages of the technology is that you can scale it up to make more complicated shapes while still maintaining the basic printing method. Instead of printing a beam at the end of this, you would attach it to a robotic arm, for example, and you're printing a complex 3D structure. So yes, it's a way to build space heritage while also selling a product and demonstrating the technology. So it's a 3-in-1 strategy, I say.
You mentioned the challenges and actually getting to test your idea, and I was really going to ask you, how can you test the feasibility of a business idea and an actual business, the actual product, when it comes to space tech? I mean, before, like you guys, now you can prove it by you're working with the European Space Agency and you're going to prove it there, but I think I'm guessing it's a long way to get there, to actually get to test it in space, because you need a controlled environment, that's for sure.
Yes, so both from technology and business point of view, it's a very long way to go. So regarding the business, we're already even from the very beginning, we are completely aware of it. We spend significant amount of time going to space events to meet relevant people, to engage in conversations, in projects together with leading space companies, with European Space Agency. It took months, I would say, to get to earn their trust, to learn who's the right person to speak to. But finally, we managed to get into projects with companies like Teleselenia Space, who's the second largest satellite manufacturer in Europe. We managed also to attract European Space Agency interest. First, we got into an incubator of European Space Agency. Now we're working on a lunar 3D printer that in the long term might be used for construction of lunar landing pads, of lunar habitats, in general lunar construction. And obviously, it's also tricky to prove that technology works with a limited budget and in a short amount of time, because everyone expects you to go to orbit to demonstrate technology works, and on the way to go to this stage to execute a number of very expensive and time consuming tests. But every time Robert found a very smart solution to prove the basic principles of the technology at every step, to satisfy all the questions from both European Space Agency and from commercial partners. So we were able to gain their trust on the way while developing the technology, and get their feedback so we could better plan for the future work.
Thank you very much. Coming back a bit to the technology of 3D printing, can you guys tell us, I don't know, in theory, I'm guessing you already know, but in theory for us, what kind of things can be 3D printed in space in the future? And you mentioned, Jakob, the lunar project, but would this open the possibility, I don't know, maybe in the distant future, but hopefully it will be not so distant, of seeing, I don't know, human colonies in space, now that you can actually prove and test this 3D printing?
Yeah. So when it comes to the longer term plans and the overall plans, there is ongoing missions to try to get the lunar base going, and that's a collaboration between the European Space Agency and NASA, amongst some other space agencies as well. But basically, the goal is to set up a base on the moon and a moon space station, so to say. We'll see how that goes, and the timelines of that is always delays, but the general interest is there. And when it comes to doing things on the moon, it's much more expensive to ship anything to the moon than it is even in orbit. Uh, it costs up 10, 20 times more. So the idea of using 3D printing on the moon is it saves you a lot of weight and money, especially if you can use some of the resources that you can find on the moon to 3D print. So for the lunar project, for example, is to show that we can use our material, the photopolymer resin, and combine it with resources you find on the moon to basically double or triple your available 3D printing material. And that saves you a lot of money, but also gives you the flexibility to mix it with different materials to get different material properties. So if you can make a ceramic, for example, or you can make insulating plastic, or you can make a conductive plastic, all kinds of different things. We need to study, and we need to come up with how to do that exactly and how does it look like. But even larger scale infrastructure, for example, there's a lot of interest in very large antennas to build for satellite communications and satellite astro radio astronomy. So you're talking about reflector dishes, so parabolic reflectors that are hundreds of meters in diameter or even kilometer in diameter, which is simply not possible with current uh, methods of delivery. So it's much more cheaper and much more economic to build them in space directly. And there's also structural components for the new space stations, like they're the ones that will replace the current International Space Station. So there are quite a few things in the near future that can be built. And of course, long term is the imagination is your limit. You can apply it to various projects and larger space stations. 3D printing complete habitats, for example, is an option.
So how would it work? Let's say in the near future, you're going on a space mission and you're bringing the printer and the polymer, and you just print what you need there, right? And
Yes, exactly.
afterwards, as the project gets bigger and you're making your technology even more sophisticated, they could, I don't know, print another printer or I don't know, stuff like that.
Yeah, so the initial use case, especially for tools, printing tools or replacement parts, is very valid and it's already proven early. There is a 3D printer in the International Space Station inside the station, so we know it works, and the astronauts printed various tools to use already. So it's a proven use case, and the long-term scenario of being able to print as many replacement parts as possible, it's definitely there. Obviously, this printing a full replacement printer is a little bit more difficult. You have all kinds of things, electronics, and so on. It's technically possible, but you need many different printers and many different methods. But it's going to take a few years until that's a reality. For now, it's mostly structural components or very simple replacement parts and tools. One of the big thing is the ability to print ceramics, for example. That's a new exciting material that's being developed right now. So then you can print full ceramic parts on the moon using a large part of the lunar environment and the material you find on there.
Thank you very much, Robert. Please tell us more about why did you start Orbital Matter? I mean, what's the mission that you've had when you first started this project, this startup, and how did you come up with the idea? I don't know what was missing, or why. How did you wake up one morning and said, "This is what we have to do"? I'm exaggerating, of course, but
Kuba can tell the story because it's quite funny. But
Yes. So we met in Berlin. We both attended the matchmaking incubation program that was supposed to bring together technical and business entrepreneurs that are looking for another opportunity. And we started speaking with each other because Robert was wearing a jacket that my previous company made for a customer. So that's how our interaction started. And then after a few days, we realized that a couple of people, because you are basically exchanging ideas and telling other people about your background. And after a couple of days, we realized that a few people told each other that we should speak together, that we have like a similar mindset, similar vision, similar level of ambition. So we already, let's say, exchanged a few words, and we had the same feeling. We started to discuss the opportunities, what we can change, what drives us, and we both realized that we are fully complementary when it comes to our backgrounds, because my background is in business, Robert's background is in hardware engineering, and then we started looking for opportunity and for a very ambitious challenge in hardware or manufacturing, because that's something that we both wanted to do. Although we had like or maybe not although, but and plus because we had those different but completing backgrounds, we decided that we can form a very good team. And then we realized that manufacturing and hardware is a huge opportunity in space, because it didn't make sense for us that you have to bring everything on a rocket, ship it to space from Earth, and it costs a lot of money to do it this way. It has multiple limitations, so we started asking why nobody's doing it. And obviously, we discovered that there's a few companies already working on it, so already working on solutions. But Robert's vision, and because of Robert's expertise, was brave enough to challenge those quite successful and quite large companies with a statement that the technology that they are using and the technological approach they're using is far from ideal. And because of his background in 3D printing, we can do much better. And we started from the assumption that in order to create something that works very well in space, we have to keep in mind the very different environments that we have to face in space. So we cannot just simply take existing hardware and adjust it for space environment, but we have to design something from scratch, having in mind those space limitations and those space environment. And we started working on the first customer feedback, let's say, not even the first partnerships or the first customer, but the first response from customers. We started working on also first technology proof of concept in order to secure first initial funding from this incubator. We had only, I think, 3 months before from the start until investment committee. So it's extremely short time for hardware and space project. So we had to be very creative. We knew that it's super risky that we can spend just like 3 months and waiting for feedback and get nothing. And then just lose a couple of months on struggling to get any information. But we are determined. We got first commitments from customers. Robert built the first prototype in his own, I think, bedroom, not even living room, and we presented it to the investment committee, and they all agreed that the vision is crazy. It's literally a moonshot, so something they were trying to convince us to look for. And because of the this early traction and this early proof that the technology works, they decided to fund our startup. And then we applied, let's say, the very same logic to all the next steps to the whole development, and I think that's why we are here.
You mentioned funding. From what I've read, you received, I think it was your first funding in 2023, another €1 million, if I'm not mistaken.
Yes, and before we also secured some funding from Entrepreneur First. So this incubator, as I called it. We also managed to to secure some small tickets from a private investor, from angel investor. That helped us survive for another few months to order some critical parts for another demonstrator, visit yet another conference to get new contacts. And then, yes, by the end of 23, we closed the first pre-seed round, around €1 million, and now is the seed funds that will let us to develop further.
I'm going to come back to the latest funding round, but first I want to ask you. I don't know how to. Let's put it like this: what's you talked about other companies doing or trying to do the same thing, or some of the things you're doing. What's your, let's say, main selling point for your commercial partners, for like you said, you're working with Thales, you're working with companies that have have something in aerospace. You're also working with European Space Agency. What's your main selling point? Why should they work with you and choose your 3D printer and what you guys are doing?
I guess the main differentiator, first of all, is the technology. So we mentioned the competitor from the US originally that was the first to attempt 3D printing in orbit. So they put a printer on the International Space Station. They showed that you can print in microgravity, and then they tried to bring it outside of the space station and show that you can print also in vacuum and microgravity at the same time. And to do that, they got a large NASA contract, about $76 million. But this goes back also to the story of the founding. Coming from 3D printing field, I was working R&D. So I always is keeping an eye on this company and seeing their progress. And I wasn't very impressed as a specialist in 3D printing. The technology they were using was very underwhelming and too quite basic. So I thought that there were better technologies that could work better, which is what we're using now. And there's the technology differentiator. As I said, with that technology they were using would take days and weeks to 3D print anything. For us, it's a matter of hours. So that speed is quite critical. The power consumption of the printing is very low. It's about 10 watts while printing, which is 10 times lower than the competitors we need, which is very important for satellites because you're operating on batteries, especially if you're deploying solar panels. So you don't have very much power to start with, and then takes multiple orbits and so on. So that's the technology advantage is clear, but it's also an advantage we have is the business side. Going back to our strategy of launching multiple smaller printers rather than try to spend 5 years on a large satellite to show that we can print large things already. That I think that's what differentiates us from the competitors, because in the case of the US company, they spent, I think, 7 years working on the satellite, and then they run out of money and went back to NASA to ask for more money, and NASA said no. So currently there's no plans to launch it, and that's means we'll probably be first if the mission we have next year goes well, to demonstrate that this technology works. So we'll have that advantage of being faster with the demonstration, but also we have a product that works and it's ready to be integrated with any satellite. So it's not a custom part that you have to spend months or years customizing for each individual mission. The idea is to have a plug and play module that we can sell to anyone very quickly. So it's a lot faster to integrate. And reliability as well, it's a big factor for us. So we optimize to have a reliable system. And all of those things combined means that we have quite good success in convincing large prime manufacturers in Europe and even in the US that we are on the right path and they should work with us.
I was curious because you mentioned, Robert, that the other guys ran out of money, and you guys not only are doing something in space tech, which is, I dare say, more difficult to test or to prove than in, I don't know, regular software, or even doing something hardware, the regular kind. But like I said, space tech, but also hardware. So you're kind of combining two difficult to fund segments. Um, how did you pitch to the venture funds? How did you pitch Orbital Matter? Because I think it's pretty challenging. You can combat me on this, if to find investors that are willing to fund something that has a longer life cycle until production. I don't know. How do you guys see it now that you have two venture funds behind you and supporting the project? Was it
I
more
guess.
difficult for you, or do you find it more difficult?
Yeah, definitely. Kuba can talk more about the fundraising phase and all of that, but I think a large proof was the fact that we were building things and we were launching things very efficiently. Our burn rate is very small. We are very efficient with our money, and
Yeah, you
we
took it step by step after all.
yes, exactly. And we built a prototype that showed that it works. We showed it to investors, and they liked it, and they liked the vision, and they liked us, and that was enough to convince them.
Very
Obviously, we had
important.
traction from the business side with all of the support we got from various companies, space companies, showing their interest in that. But yeah, it is a longer timeline. The differentiator is that we are doing it much faster. So we managed to secure a lot of launches, some of them for free from the European Space Agency, some of them paid by us. But for example, we already had the previous launch, and we are having two more scheduled launches next year, and then probably another launch in 2027 as well. So for a startup of our size to have 4 or 5 launches secured is quite unusual in the space field, and I think that's helped a lot with building the credibility first of all, and getting the investment behind it.
Thank you, Robert.
Yeah, and I can only add that what differentiates us from the other startups in this field is also that the potential for the market and for the change we can make in the space industry. We are one of few startups in the space industry. I'm quite sure to say that that can redefine the, a very large portion of this industry that can totally flip how the construction of the space infrastructure works. And we managed to find investors who are brave enough to understand this vision, to believe in this vision, and who are not looking for compromises and are eager to support ventures like ours with with a great opportunity to become leading the change in the industry like space, which is, by the way, already by definition something very hard and innovative.
Thank you very much, Yago. Coming back, like I said, to the investment you received now from early game, how will it help you? Let's say for the next year, what's your timeline, and how will you use this money? What do you need to, I don't know, let's say test? Which are some things that you're going to test in the next month using this money, or it will help you grow your operation? I don't know, bring more people to the team. Like, how many people do you have now in the team?
Right now we're five. So we're also looking for new engineers. So we are keeping the team quite small, but we're always looking for the best talents, for ambitious people who are also experts in their own field. So it takes quite a lot of time to find the right person. It's also quite challenging to fit all the positions, but because of this approach, we managed to be quite lean as an organization. We managed to keep the whole teams relatively small and still keep the high pace of the development and to deliver. And when it comes to the goals for this fundraising, the main goal is to bring our first product to to TRL 8-9, to demonstrate it in flight, to demonstrate it in orbit, and to be ready to commercialize it. So that's the main goal behind it. We plan for several launches, as Robert said. So both commercial launches for which we have to pay, which are faster to execute, but we're also looking and already securing opportunities from European Space Agency, where we don't only get a free launch, but we're also getting engineering support from European Space Agency technology officers. They're also learning about our technology, which also translates to higher trust from both institutional and commercial partners. Robert can probably tell you more about details about the technology, how the money will be spent. But when it comes to the general goals, these are the most important things we need to achieve.
Thank you very much. Well, just 5 people. You're amazing doing all this stuff in just 5 people and a dog, from what I hear with Robert. Tell us more when it comes to the technology. What's the roadmap?
Yeah, so with the people, we're very efficient when it comes to hiring, and we have good engineers on board. That means that everybody's putting in the work and being creative when it comes to how we spend the money. Uh, when it comes to the technology plans for the next year, is basically going to be spent on the in-orbit demonstration, manufacturing, scaling up our manufacturing capabilities. We do most of the manufacturing ourselves in our own workshop, and basically it will mean that we have 2 launches next year. So one of them is self-funded via a launch with SpaceX. We'll have a 8-unit satellite that we develop ourselves in-house that will demonstrate the deployment mechanism deploying solar panels, which will be one of our product offerings. And then we have a second launch, the one that's funded by the European Space Agency, and that will be just for the standalone 3D printing. And together, the idea is to show that the technology works and that we can use it for something useful in space.
Do you also have some kind of timeline? When do you think that the launches will be? I know that things change. Unfortunately, they don't always work out the way you want it or plan them.
Yeah,
So
We can say that in the next 2 years we plan for at least 3 launches. Yeah, so the exact time will be announced surely. So we are not publicly speaking about the exact dates, because as you mentioned, it can always shift. So we are not still like completely open about it. But that's what we can say. That in the next 2 years we'll plan for 2 launches, and you can be sure we'll announce every opportunity and the milestones we achieved.
looking forward to them. Thank you, guys. And Robert, you mentioned something, and I was just going to ask you if it's in your future timeline. You mentioned the production facility. Now that you're doing them in your own workshop, but I'm guessing that once you're going to get commercial traction and you'll have orders and many more clients, I think that you will need a larger production capacity. Am I correct? Have
Yes,
you thought
definitely.
about this?
Yeah, so we're thinking about it, and we're doing a lot of the manufacturing ourselves. We have a CNC, for example, and we do all the prototyping and the parts ourselves as much as we can. This is not only for cost, but it's mostly about speed. So ordering any parts from a third party for CNC, it takes weeks, 2 3 weeks at the minimum. So for us, it's much faster to just do the parts ourselves in one day and try them out and prototyping wise. But when it comes to scaling up production, initially we'll do most of the work in our current facilities for the first products, but we will need to surely scale up when multiple CNCs and assembly and testing facilities, which we plan for uh, the next milestone. So following the demonstration of the product.
Do you also plan to raise anytime soon, or do you think that what you've gotten from early game will suffice for the next year or so, for the or at least for the next three launches, like you said, or is it
Yeah,
an ongoing process?
so both. Yeah, so the answer to both questions is yes. So from one hand, it's enough to fund those free launches to keep the operations running for another at least 18 months. But obviously, it's ongoing process. We are constantly networking with investors. There's also significant. The significant opportunity for funding is also institutional player, which is basically in Europe, European Space Agency, and also European Commission to some extent, although they are usually cooperate. And we are always trying to meet new people or to deepen the relationships that we already have, and to increase the chances for getting more funding, another contract, or stepping into another collaboration. So we can speed up the demonstrations and speed up the technology development, so we can get a better feedback regarding the products we develop, and eventually to be faster with commercializing and better than the competitors.
Well, thank you very much, guys, and thank you for your time. Before I will leave you to get back to work and do those amazing things that you're doing, I have just a couple of more questions for you. And I'm going to Robert because, like I said, he's a Romanian. Is my curiosity as a Romanian, how does it feel for you to be part of a startup that's born outside Romania? Do you think that it's easier, or I don't know, more challenging to do this kind of project in Western Europe, or than it would have been in Romania? Do you think that you would have had this opportunity if um, Orbital Matter would have been born in Romania, or at least launched here?
Yeah. So when it comes to the geographical location, it certainly affects a space startup mostly due to the geo-return policies of the European Space Agency. So basically, each contributing member to the European Space Agency contributes to the budget overall, and there with the expectation that the percentage of that returns back to the original country. So, for example, in the case of Germany or Poland, they pay a few hundred millions a year, and they expect up to 90% of that to come back to their own industry. And that's just how the European Space Agency is founded, and that's how it works. In the case of the Romanian Space Agency, they are not contributing so much. They're mostly focusing around education for the space field. So one of the challenges with starting this in Romania would be to get the support from the budget. For example, if we apply for any project with the European Space Agency, that the location counts. So you have to specify where is your base, the company is founded, and you have to go through your national agency to get the letter of support saying that they're willing to support you in this project, in the sense that they are okay with money being allocated from the country's budget that is in ESA to go to your company and so on. So that's always a challenge. And then when it comes to the other factors such as access to funds, Western Europe is certainly easier in some regards. I would say that now Romania and Central Europe in general is catching up very fast, and obviously Early Game Ventures is supporting us, so that's very good.
You got
I'm
support
sure.
from a Romanian venture capital fund.
Yes, exactly. Eventually, I'm sure if it was started in Romania, we would have gotten in touch with them in the same way. But starting is the hardest thing. I think without this very early support we got from that program in Berlin, it would have been hard to, first of all, meet each other and then start something and dedicate ourselves 100% to this, because obviously it takes money to prototype and it takes money to do all the business development and so on. So it's certainly possible if there were similar opportunities early on in Romania. And it's just in our case, it was a weird situation of meeting up in the first place, which wouldn't have happened with that early program.
Yeah, maybe it would have taken you longer to get to the point where you are now.
Yes.
When if it would have been somewhere else, or at least in Romania. What have you guys learned from, on a personal level, from this experience so far of being founders? And what would you say to a wannabe founder or a future founder, a teenager that is thinking about starting a business, maybe in space tech, maybe just a business? What's from your experience so far?
Yeah, I guess I can start. It's for me, I think the biggest thing was learning that it's always better to ask. So a lot of times you feel afraid to just ask people or companies for help or to information. Early on, we were just cold approaching all kinds of people and companies just to learn more about the industry and what their needs are. Of course, we got ignored a lot, but some people did answer and it was very valuable to us, which really helped us determine what the product should be and how to do it best. So getting the courage to ask and try to have conversations with the people was something we had to learn, coming from obviously industry. There's a lot of bureaucracy, there's a lot of levels, so if you gotta ask permission first to do anything. You don't have to ask anyone for permission if you're an entrepreneur. You either choose to do the right their path, or you find out later and you change. If it's not too late, you can change and adapt as you go along. So I think that's for me the biggest thing.
Thank you, Jakob.
For me, as I already have experience with running companies and with different co-founders, I would have to say that the most important thing for me here is that we work very well together with Robert. Robert's a great co-founder, and we understand each other's roles very well and the split between us. So every discussion we have, even every argument, let's say, and disagreements that we have is solved very well. We always use I would say maybe not only logical. Very often the arguments are also emotional because it's our company, but we always after discussions we always reach an agreement. We can always feel that we can support each other and that each of us is fully committed to the success of the company, which wasn't the case always. And I think that's the most important thing, because it's not only critical for the success of the company, because you cannot just break up and find another replacement for a co-founder, but it's also super important for each co-founder's mindset and for a peace of mind that you're putting 100% effort in this company, and that the other part is also fully committed to it. So I believe that's what I finally learned after starting multiple companies, and that's what I really value in this company and in Robert's approach.
Cool. Thank you very much, Jacob. And my very last question for you is not exactly a question, but a curiosity, because I think that when people say space tech, I don't know, they're thinking about things that are being researched today, but can be applied in a, let's say, very distant future. I don't know. And some things may seem absurd for a lot of people. And I wanted to ask you guys to, I don't know, give me an example of let's say an absurd thing from the past that became reality when talking about space.
I think
Okay, so
that our whole project was perceived by a large number of people like that. But Robert can probably be better in explaining that.
I mean, there's a long list of technologies that initially seemed science fiction that now are a common day, including, like, for example, the global positioning system, the GPS. Very few people remember the old times where you had to navigate using a map, and then the GPS was started as a military project initially using satellites in orbit, and everybody got access to it. Nobody expected it to be as good as it is, but now basically everything relies on GPS to work, including from shipping to planes to just your day-to-day car. And that's one of the things. There's always technologies that seemed ridiculous beforehand that got discovered because of the space industry, including the internet could be arguably one of the results of it. So it's a long stream of technologies, but I think GPS is the best example of that.
Thank you very much. Thank you very much, Robert. Thank you very much, Jacob, and best of luck to both of you. Congrats once again for the latest funding round, and we look forward to hearing news from you and about successful deployments. Thank you guys for watching us today, and remember that we are getting together every day on Startup.ro, on our Facebook and LinkedIn pages, and on our YouTube channels. Thank you for watching us. Bye, everybody.
Thank you as well.
Thanks a lot for hosting us.